Hey everybody, welcome back to our video on discs. The first video took care of this side of your worksheet. Second video, we're going to finish up here, and this will go much faster because we know what we're doing now. So take a look at example 5. It says, find the volume of the solid generated when the region bounded by y equals root x, and the x-axis from x equals 0 to x equals 9 is revolved about the x-axis. So I've already drawn it. This guy right here represents the square root of x from 0 to 9. Here's my x-axis, and so I shaded the area between the two. And we are spinning around the x-axis, so I'm going to give my loop-de-loop right there. Let me reflect it across the x-axis so that I can get a better idea of what this is going to look like in 3D. So you have to envision picking this region up and spinning it around the x-axis. So can you kind of envision what that would look like? Can you think of a 3D figure that might look like that? In years past, I've gotten answers like a bullet. I've gotten answers like dots, the gummy candy. So you might be able to think of something different. Those are just some things I've gotten over the years. Now we've got to figure out what our cross-section is, because once we figure out the cross-section, we're just going to basically add up the volume of a bunch of them. So cut perpendicular to the axis you're spinning around. Look inside. Hopefully you see a disc. Width, thickness, right here. Okay, now again, you're going to have a bunch of these. Little ones, medium-sized ones, large ones. It depends on where you are, but they're going to change and grow and ebb and flow with the contour of this top function. So each radii is going to be measured from the x-axis, which you can see the x-axis is the center of each one of these discs. So you're going to measure your radius from the x-axis on out. And so the radius in terms of x, well, if y is equal to the square root of x, and my y value that I seek is the radius, then radius is equal to the square root of x. Okay, so let's get volume. Volume equals definite integral from 0 to 9. Remember, when you spin around the x, everything's in terms of x. Ooh, that's kind of light. Hold on. V equals definite integral 0 to 9. Okay, and then we need the area of the circle. So pi, here's r. Just don't forget to subtract 0. Top minus bottom squared. Top minus bottom, again, you're taking the top minus the 0 because that's the bottom. And when you take the top minus the bottom, you get the purple's length, dx. And the rest is history. So the final answer, you put in your calculator. Math 9, 0 to 9. We got a pi, parentheses, root x minus 0 squared dx. 127.235. Okay, told you this would go faster. Now that you understand it, let's go to the next one, the final example. Again, finding a volume, this time bounded by y equals x cubed, the y-axis, from y equals 0 to 8. So you see I have that ready to go. I've got x cubed right here. I plotted a couple points, 0 to 8 on the y and the y-axis. So there you have it, right here. If I mimic that across the y-axis, it's going to look like this. And if you think about it, this almost looks exactly like this one did. It's just kind of turned 90 degrees. So it's going to look like this. Reminds me of like an acorn or something, but you can think of what it reminds you of, get a good glimpse of it here in 3D. It's spinning. creating a three-dimensional figure. Now, the cross sections, again, here comes the cut, perpendicular to the y-axis, boom. If you cut into this figure like such, you would create some cross sections. Here's one such cross section. Here's its little thickness dy. And we're going to add up an infinite amount of these. So we take one volume, move it through the space 0 to 8 with the radii. Now remember, the radii are determined by, from the y-axis outward here, and they're really determined by the right function minus the left function. And so in this case, since y is equal to x cubed, and we know that the radius is x, we've got to get x in terms of y, so x is going to equal the cubed root of y. And since x is the radius is the cubed root of y. Beautiful. So, and that's going to be no matter where you go. Here, yeah, it's going to be smaller, but the x is still determined by where you are here. If you're up top here, don't worry about it. It's going to be found by this function. Okay, so volume will be, now remember, spinning around the y, everything's a y, so definite integral. The y values are 0 to 8. 0 to 8. We've got the pi. Here comes radius. Cubed root of y minus 0 squared dy. That's dy. Remember, dy is the height. And the rest is history, so we put it in the calculator. We've got math 9, 0 to 8, pi times. To find cubed root, you just press math 4. Again, I'm just going to type in x minus 0 squared dx. And I am getting 60.319. All right. Last but not least, the bottom, just want to talk to you about the rules, and you can just pause the video to write these down. I've just sort of summarized it. So if you can see there, when finding volume, when making your cut perpendicular to the axis you're spinning around, here it is. If you're spinning around the x-axis, your volume is simply the definite integral from the two x values that bound the region of pi r squared dx. Your r is the top function minus the bottom function. And when I say top minus bottom, this is of the original graphed region. And you need it in terms of x. So I said f of x minus g of x. And again, for us today, the g of x was always 0 because we were always bound up against the x or y axis. If you're spinning around the y, very similar, but now your volume is from y sub 1 to y sub 2, pi r squared dy, the right function minus the left function. These must be in terms of y, so f of y minus g of y. So make sure you're starting to memorize those formulas. Hopefully this made sense. It's a little more involved, and thanks for watching.